Okay, so we are looking at the reduction formula. We just evaluated the reduction formula for tan to the power n for the indefinite integral. So let's look for the definite integral, whereby now you have your limit. So the last time we said in is equals for the sine for sine nx dx, we said sine nx dx is equals to minus cos x sine n minus 1x over n plus n minus 1 over n in minus 2, right? If you evaluate sine to the power n x. So now, what if you want to evaluate now from pi over 2 to 0? Just as we can see from this problem, we want to evaluate this. Now you have the limit. That means this is the same thing as minus cos x sine, which means even here you're going to put your limit, which is pi over 2, 0. And when you look at this is actually the same thing as the integral from 0 to pi over 2 of sine n minus 2x dx, right? This part is the same thing as this. So we will just keep this is going to be plus n minus 1 over n minus 2. We assume that even this is with the limit. So from here, we can further simplify this. If we start with the upper limit, cos pi over 2 is what? It's 0, which means the entire thing is going to be 0 minus, if we substitute 0 here, sine 0 is what is 0. So this is plus n minus 1 n minus 2. So which means in is equals to n minus 1 n minus 2. So this in is evaluated from 0 to pi over 2. Don't forget that. So we are saying it reduces even further to this point, to this formula. The minute we include the limits here, it's going to reduce to this reduction formula. So from here, we can iterate this. We can iterate this. How? So we can use the same formula to evaluate in minus 2. So in minus 2 is equals to, where there is n here, we substitute n minus 2. So it's going to be n minus 2 minus 1 over n minus 2. N minus 2 minus 2, right? So which means in is equal to n minus 1 over n. So where there is n minus 2, we substitute this. So this is n minus 2 minus 1. This is n minus 3 over n minus 2. N minus 4, right? Which means now in is what? It's n minus 1 n times n minus 3 n minus 2 times in minus 4, right? So from here, let's do n minus 4 again. So in is equals to n minus 1 n minus 3 n minus 2, and then n minus 4, which means from the same way there is n here, we substitute n minus 4. That is going to be n minus 4 minus n minus 4 minus 1 over n minus 4 times n minus 4 minus 2, right? So this will be in is equals to n minus 1, n minus 3, n minus 2 times n minus 5 over n minus 4 times n minus 6. As you can see, this will iterate, will go on and on and on and on, but later what determines the limit? So we evaluate this by saying when n is even, what is going to happen to this iteration? When n is even, which means when we are saying when n is even, which means n here can be 6, right? Which means we are going to have I naught, which means there's a point where you're going to have I naught when n is even, which means therefore when n is even, in is equals to n minus 1, n minus 3, n minus 2, n minus 5, n minus 4, which means it will go to a point of a naught when n is even. So, and then we're saying when n is odd, what do we get? When n is odd, which means if this is 7, which means going to be 7 minus 6, right? If this was n minus 8, if n was 9, we're still going to get 1. 7 minus 6 is 1. What does this tell us? If n is odd, we are going to get n minus 1, n minus 3, n minus 2, n minus 5, n minus 4, and then this is going to iterate to n1. So now let's find the value of a naught and a1. So a naught is the same as the integral from 0 to pi over 2 of sine naught x dx, which is the integral of from 0 to pi over 2 dx, and then this is x pi over 2 0, which is equals to pi over 2. So a naught is equals to pi over 2, and then a1 is equals to 0 pi over 2 sine x dx, right, which is equals to minus cos x pi over 2 0. So cos pi over 2 cos 90, it's 0 minus cos 0 1, so this is 1. So when n is odd, we have 1 here. When n is even, we have pi over 2. So we can say that the integral from 0 to pi over 2 of sine nx dx is equals to n minus 1 n dot n minus 3 n minus 2 n minus 5 n minus 3, right? Hopefully I'm not messing this up, is equals to n minus 2 4 3 5. Sorry, this is 4. This is n minus 5, n minus 4, and then it will be n minus 7. This is n minus 6, right? So this will continue to I naught. I naught we found that is pi over 2, and then also you write here when n is even, and then you're going to have n minus 1 n minus 3 n minus 2 n minus 5 n minus 4 n minus 7 n minus 6, and then this also goes to 1 when n is odd. So this is your solution. If you evaluate the limit if you have the limit of integration. So this is your solution for sine. You do the same thing for cos, you do the same thing for tan. You determine when n is even, when n is odd, and then you just write your iteration.